Hi everyone, myself Bhagyashree and today I am going to discuss about the interview question in the system design, which you can see which you can see for your upcoming interview preparation, which you can take and prepare on that. And let's start with that. And because if you are looking for the product based company or mang based company, the system design is a very crucial round, and in that we are developing the solution, and for that it is a stable improvement performance, all the factor which we have to be see. So how we can decide how what operation we can do, because of that the operation or the system become more flexible, more responsiveness, more robust. Behind that, this is the concept which they as a developer we have to be know, and the interviewer also asking the same question: if this is the application, how to improve, how to give the performance issue over there. So let's start with that, and I think it will be very great content for you all, and it will be beneficial as all aspect in the system design. First question, you can see the question is about the sharding. And what is the sharding in the system design? So sharding is a technique to horizontally scale a database by splitting into multiple independent server called the shards. The definition of the shards, like multiple independent server, is called the shards. Benefit of the sharding in the system design: improve the performance, improve the scalability, increase the scalability, I can say. Performance and increase, like we can say, each shard handle the less data, leading to faster queries and processing. Second, increase scalability, like adding more shards easily expand the database capacity. And on this, I also give the like real time example also how this sharding we are handling the real time scenario. If you are using any system or any application, any way, social media app, so you can see what is the responsiveness, what is the performance behind that, what is the logic we are applied over there. So for the real-time example, in the social media app with the millions of users we have, so storing all the data in one server would be overwhelming. So we can shard based on user ID ranges. Like shard one, we can see user ID with ID number 1 to 1 million will be in the shard one. Similarly, in the ID, in the 1 million to 2 million, we have shard two, like that. So we are keeping the data according that. So it will be not having a more load time, more responsive time. Okay, it will be like we are separately distributing, and that's why this responsive of the application will be a very good. Now in the user query are directed to the specific shard holding their data. Like I ask a request over there, and my request belong which ID, it will be goes on that shard. If like you can see in the 1 to 1 million in the shard one, 1 million to 2 million, then in shard two, my if my request is coming under the first one, it will be go in the shard one. Similarly for the second, it goes to the shard two, like that. So individual shard handle a smaller workload, improving the performance, and adding more shards scale the database as the user base grow. And in like how we have to be like sharding also bring the complexity. We are doing the sharding, it's okay, but in that also we, if you are not properly managed or properly created, sometimes it also give the complexity. In what complexity which we can see, the data distribution, determining the right sharding key, managing data movement across the shard is crucial. So we have to be very careful while designing this key on which ranges it will be have to be occupied. Second, joined and complex query. Combining data from the multiple shard may require additional logic and can be slower. Because of that, it will be a like complexity. And if you're designing, so you have to be properly careful and maintain the query and join on that when we are comparing or when we are fetching the data from multiple shards. Then second question, you can see again we have a system design purpose. So what are the bottlenecks in system design? Bottlenecks means in system design are point to or component that restrict overall performance, and identifying and addressing them is a crucial for optimizing the efficiency. And common bottleneck include like CPU bottleneck, CPU bottleneck means, again I can give the like bottleneck if you not get idea. Bottleneck means you want to like my response should become 100%, but due to the bottleneck there is a restriction, it will not give the 100% completely. So that's why the system become a less responsive. So type of bottleneck which we can see, because of that this performance, scalability, robustness of the application would be a not good. First, you can see we have a CPU bottleneck. When the CPU cannot process the data fast enough to meet system demand, it become a limiting factor. Second question, we have like memory bottleneck. Insufficient RAM or slow memory access can hinder the data storage and retrieval, slowing down the system. So one of the like memory bottleneck also. And third, you have like storage bottleneck. If you not have a sufficient data storage, because of that also we are not getting the proper response over there. So slow read and write speed is also limited. Limited storage capacity can impact the system performance, especially in the data heavy application. Fourth, we can say in the database bottleneck. Inefficient database query, poor indexing, not applied on the table level, database level. So contention can be significantly affect the application performance. So particularly in database dependent system, the database bottleneck also happening. So now we have like CAP theorem. CAP theorem is a theory. It is also already proved by one of the scientists, and that's why it is applicable and designed on the system. It states that the distributed system or database can provide only two out of the following these properties. Three property like we have a consistency, availability, and persistence. So out of three, every time two property we are achieving, not all the three at the same time. Similarly, like you have acid property, consistency means in that state of the system before and after transaction should remain the consistent. And availability, they state that the source should always be available. There should be non-error response, because if you are accessing any application, you want some data, that system should always be available. It not goes like if I'm searching on the day, it will be giving the answer. If I'm searching on the night, it will be not giving the answer. So your system should be availability heavy. Next, we have a partition tolerance, in that even when the network communication fails between the nodes in a cluster, the system should work with. Some application you can see if you have some network issue over there, but still they are working. So this is a property and definition of the CAP theorem. Because of this, our application should perform very well. So by the CAP theorem, all of this property cannot be achieved at the same time. So that's why at the same time we have to be CA, AP, CP, like that of things which we can apply. You see in the diagram also. CP category, CA category, AP category. In the CP category, what means? Pick two. We have partition tolerance, it is consistency and its availability. So in the CP, you can see there is a risk of some data becoming unavailable because we are not considering the A. So example, MongoDB has HBase, Memcache, Bigtable, Redis. In the CA category, you can see network problem might stop the system. And in this AP category, client may read inconsistent data. Example like we have a Cassandra or CouchDB. Next question we have a what is the difference between the horizontal and vertical scaling? It is also used for the performance purpose. You can increase your performance applying this scaling, and there is a variety of there like horizontal and vertical scaling. In the horizontal scaling, it involves like adding more machine or node to a system to distribute the load and increase the performance. In the vertical scaling, what we can see involve increasing the resource. In the horizontal, we are adding the machines, but in the vertical, we are increasing the resource like CPU, RAM, storage, etc. We have a like 50 or 60 GB, we are increasing the 32 like that. So on a single machine, it improves the performance. But in the horizontal scaling, we have a server 1, server 2, server 3 like that. So fundamentally, we can see what is the difference between them. Horizontal scaling and vertical scaling have a data management. So in the horizontal scaling, data management like scaling horizontally typically relies on the data partitioning as each node only contains the part of the data. But in the vertical scaling, their data reside on a single node, and the scaling is accomplished by the multi-core, primarily by distributing the load among the machine's CPU and RAM resources. For the real-time example, which application using the horizontal or which are using the vertical scaling, you can see Cassandra, MongoDB, Google Cloud Spanner using the horizontal scaling, vertical scaling using in the MySQL and Amazon RDS. And downtime possibility, in which you can see in the horizontal we can scale with less downtime by adding the additional computer to the existing pool, because you are no longer constrained by the capacity of a single devices. But in the vertical, there is a upper physical limit to a vertical scaling, because you are increasing your resource at a certain time. It is given a limit, like it after 64 or after 32 it will be not get increase. So, which is the scale of the current hardware. Vertical scaling is restricted to the capacity of one machine, because expanding over that limit can result in downtime. For the concurrency model in the horizontal and vertical, concurrency model in the horizontal, like as it see, it entails the distributing jobs among the devices over the network. In the distributed programming, like several patterns are connected to this model: MapReduce, master worker, backbone, and many spaces. But in the vertical scaling, it acts as a like actor model. Multi-threading and a-process message forwarding that are frequently used to implement the concurrent programming on multiple platforms. For coming to the message passing, data sharing is more difficult in distributed computing, because isn't shared address space. Since you will send the copy of data, it also increases the cost of sharing, transferring, or updating the data. In the vertical scaling, data sharing and message passes can be accomplished by the passing a reference in a multi-threaded scenario, since it is reasonable to presume that there is a shared address spaces. So choosing between the horizontal and vertical scaling depend on the specific need. Here are some general guidelines you can see when you use the horizontal and when you use the vertical. So in the horizontal scaling, for handling the high workload and surface in traffic, building high resilient and available system, and processing a large data set efficiently. For that, you can go for the horizontal scaling. In the vertical scaling, simple workload and application, rapid deployment and testing, cost efficiency for the low workload. Okay, now after scaling sharding, we have to be design the API. So for the API design purpose, also have a principle. So which principle you have to be used, and each principle what is the mechanism which we can apply in the creation of the RESTful API. So the question is like they are telling describe the RESTful API design principle. So we have first like mechanism in the uniform interfaces. In this, like consistent resource naming and action using the HTTP method. HTTP method like get post put delete. In the client server, separation of concern between the client making request and server handling them. In the third variety, you can see we have a statelessness. Each request contain all information needed. Server don't remember past request. And in the fourth one, we can see we have a cacheable property. In this, resource can be cached by client or intermediary for the better performance. And in the layer system, intermediary can be placed between the client and server without the affecting the communication, like reverse proxy. You have heard about that. And next we have a code on demand. It is optional, but server can send the executable code to client to extend the functionality. So these are the principles which is lead to a well-designed, predictable, and scalable API. For designing the REST API, you have to be keep all this stuff in the mind, which will be giving the more good way to performance and responsiveness purpose. Next question we have like, if you have REST API and SOAP, which one you have to be select services? So when deciding between the SOAP and REST for the web services, we have to be consider the some of the property or some of the key points or factor which can be suited for the different requirement. First one like nature of the data or logic exposure. So basis on the nature of data, we have to be choose we are going with the SOAP or REST. In the SOAP purpose, we have to be like use for the exposing the business logic. In the REST purpose, we have to use for the exposing the data. So both are difference between them. You can see we have business logic and data. So if you have only concern about the data, you can go with the REST. Otherwise, you can go with the SOAP. Second, we have a formal contract requirement. If we have a SOAP services, provide the strict contract through the WSDL. If have a no strict contract requirement, you can go with the REST. Coming to the data format also, when we are consuming the data, there is a data format. It is a JSON or XML, some other. So if you have a limited support, you can go with the SOAP. If we have a support for the multiple data format, you can go with the REST one. Again, we have a Ajax call support. Ajax calls means like we having a callback functions. So in the SOAP, it is no direct support, but in the REST we have a support like XML HTTP request for the Ajax call. And next we have a synchronous and asynchronous request. In the SOAP we have a support for both sync and async. In the REST we have a support only for the synchronous call. Again, for the statelessness requirement, SOAP no, but in the REST yes. Because of this statelessness, we are using the JWT token authentication mechanism in the REST API creation. Security handling in the SOAP like prefer for the high security need. REST securely depend on the underlying the implementation. And in the 8 point, we are considering like transaction support. SOAP is like provide the advanced support for the transaction. REST have a limited transaction supports. And next we have a bandwidth resource uses. In the SOAP we have a high bandwidth due to XML data overhead. In the REST we have useless bandwidth. For the development and maintenance easy purpose, we have SOAP is like more complex, while the REST is like known for the simplicity, easy development, learn easily, testing and maintenance. Okay. So after API creation, rules and all, we have to be see about the CDN.